Okay, so you can see here, I have your original problem, and then the answers, and I blocked out the two that you didn't have done yet. But I want to make sure we understand really what's going on. And you said you already did the partial derivatives with respect to x and partial with respect to y, and then you set them equal to 0. And so let's make sure we understand why. You set it equal to 0 because we're looking for maxes and mins and saddle points, or aka in 2D, it was very simple, or much easier, where I said, if I gave you a graph and I said, where's the maximum, or a relative max, you'd say it's right there. And what was the slope of that max? Well, the slope is 0. And then same thing for a minimum, it has the same property that slope is 0. So in 3D or 4D or 5D or however many variables we have, we can use the same logic that the derivative, when set equal to 0, is going to give us some critical point. So we take each of these, set them equal to 0, and now we start solving. So when I solve this, I end up getting x equals 0, y equals 0. So therefore, I have a critical point with an x value 0, a y value 0. But to get the z value, I need to go back up to here and find what f of 0, 0 is. So when I substitute that in, I end up getting 1. So therefore, I have a critical point at 0, 0, 1. Now note, your answers, what you typed in here, notice this is just asking for the x value, the y value, both of them were 0, 0, and then you just found that the z value was 1. This value is completely independent of any of the derivative stuff, any of the setting equal to 0 and solving. It's just saying when you substitute in x and y for 0, 0, you get out 1. So what this answer right here is asking you is just saying when you put in 0 and 4, what do you get out? So here you'd put in f of 0, 4 and see what that equals. Now, because we just did all of our derivatives and we found that there's only one critical point, that one critical point is right there. So therefore you can say, I know, even though they're having me find this point and this point, I know they are not extremum, they are not mins or maxes or saddles. They're just not, because they didn't give us a derivative of 0. So that's essentially it for the problem. But now, to figure out what this is, to figure out if it's a min, max, or saddle, all we have to worry about here is using our d-test, using the second derivative test. So we're going to substitute in for our derivative. The book doesn't use x and y because it's a little misleading, but I'm just doing it because for some reason I have found this semester that students like it better if I do it this way. But what we're going to do is substitute in our x and y values of our critical points. So this is saying 0, 0. So now I need second derivatives. So the second derivative of f with respect to f, we can see if the first derivative, df dx, was for x, then second derivative would just be take the derivative of that, which would just leave us with 4. And then similarly, second derivative of f with respect to y, that would be equal to 8. Then last but not least, we need the derivative of f first with respect to x, then with respect to y. And we can look back here, because we've already done the derivative with respect to x. So now when I do this with respect to y, there are no y's in it. So therefore, that just makes 0. So now, filling in for my d-test, excuse me, got a little messy over there. You know what, I'm going to just scoot this stuff down, or scoot it over. That's what I will do. I just left my parenthesis off. Okay, here, I'll scoot that over. Okay. Don't you wish you could do that on your paper? Just kind of scoot everything over, give yourself some more room. Okay, so now, and actually, you know what I will do? I'll scoot it down as well. Come down. There we go. All right, I keep losing these parentheses, but that's okay. All right, so here we go. So we're going to plug in our values. Second derivative with respect to x, that was, I forgot already. Second derivative with respect to x, I lost it. Where did it go? Well, anyway, it's 4, because I can see it from right there. Oh, there it is. 4 times second derivative of with respect to y, that was, maybe it's over here. There it is. 8 minus, now this one was just 0, whoops, squared, 0 squared. So that's going to give me 32. So d of 0, 0 is 32. So what does this mean to me? Well, first thing, what I'm seeing here, both of these are concave up, which means they have minimums. So if I have a minimum in the x direction, a minimum in the y direction, and then my interaction term isn't big enough to drag me out of this and down into the negative numbers, it's still staying at positive 32. So therefore it stays a minimum. If this number was big, so big that would drag me down, then I would have to say it became a saddle. So for right now, I'm just going to say this is a, this is a minimum. So therefore I know my critical point of 0, 0, 1 is a minimum. I hope that helped.